All right. So thank you very much for the opportunity to present at this workshop. And I think special thanks goes both to Victor and also to Carlos. So to Carlos for making me aware of this workshop about a week and a half ago, and to Victor for allowing me to present here today, just a week before the workshop, which is fantastic. And thank you very much for that. And before I say anything else, I need to highlight a thing about affiliations. So this is a paper of Martin Wheel, who's at King's College London. And my day job, I'm a market economist at T. Rowe Price, but in my night job, so in my free time, I also do some research. And for the purpose of this presentation, I'm affiliated with King's College London and the CEPR. Nothing that I say here should be attributed in any way to T. Rowe Price. And now that I said that, let's take it away. So the title of this paper is, what are the macroeconomic effects of state-dependent forward guidance? And I think it's probably one of the first papers to explore this question. Oh, okay, let's see. There we are. So so this is basically the outline of the presentation. I'll motivate this question a little bit. I will sort of demonstrate what kind of theory I'm going to use to try and provide some robust identification restrictions. And that's really a simple neo-Keynesian model as in Adam and Billi, which I think Martin Seneca just referenced in his presentation. And then in the empirical approach, I will add the mean and the standard deviation of short rate expectations 1 year ahead to a standard VAR. And I will identify some state-dependent forward guidance shocks with both narrative sign restrictions and also the proxy VAR approach using these data. So looking at sort of the deviation or the standard deviation or dispersion of short-term rate expectations by either consumers or professional forecasters, obviously is quite similar to what Carlos was speaking about yesterday. So why is this a relevant question? And why did I choose to study the UK in particular? So G7 central banks adopted state-dependent forward guidance in response to COVID-19 pandemic. The Fed did it in September 2020, the ECB since 2019, and also thereafter, and also the latest forward guidance that they gave in July is also state-dependent on the inflation target. However, one of the issues here is that I think one of the reasons that there is no previous time series econometrics on this work on this issue is because the Federal Reserve state-dependent forward guidance, both in December 2012 and September 2020, more or less coincided with an announcement of open-ended QE. And similarly, September 2019 ECB state-dependent forward guidance also coincided with the announcement of open-ended QE. And it's really hard with time series analysis to separate these two effects. If you have so few QE and so few forward guidance observation, I would say it's probably almost impossible to look at these other countries and cleanly identify the effects of state-dependent forward guidance. Now in the UK, state-dependent forward guidance was announced in 2013, 1 year after QE3 was announced in the UK. And I will hopefully show, hopefully convincingly, that this allows us to cleanly identify state-dependent forward guidance separately from QE in the UK in these data. Obviously, as you all know, there's a ton of work there's a ton of previous work on forward guidance. Most of the previous work really focuses on theoretical issues, namely the forward guidance puzzle and some solutions to that. And I guess there are very few empirical papers. So one other paper that looks at this is Bundick and Smith, and they estimated a VAR on US data. But as I said before, out of 11 US forward guidance announcements coincide with QE. So again, I mean, even in their paper, they don't make the separation. It's really hard to know, at least in US data, whether we can attribute the effects to forward guidance or QE. So what does this paper do that's different from these other papers? So I think it's the first paper to actually examine state-dependent forward guidance empirically. And for that purpose, we're just going to propose a very simple neo-Keynesian model of state-dependent forward guidance based on Adam and Billi, which I think is one of the first papers to look at the simple neo-Keynesian model at the zero lower bound, where there's basically a stochastic shock. And our idea here is that we'll basically have a stochastic demand shock that can push the economy below the zero lower bound at any point in time. And then the idea here is to model forward guidance as a policy change. That means that interest rates are only raised when the Taylor rule indicates that the policy rate is 50 basis points above the effective lower bound. So essentially, rather than raising the central bank immediately, the central bank waits, and this waiting time depends on the state of the economy once the economy is at the zero lower bound. And what we do then as well, we solve this model with many different plausible parameterizations to derive robust sign identification restrictions. And then I identify UK state-dependent forward guidance shock with both a VAR and a local protection approach. So what I do here is we really use the timing of UK state-dependent forward guidance when it was announced, and model the predictions with the narrative sign restrictions and proxy SVAR approaches. And I think the most important key thing here for me is that we try and leave output and price responses unrestricted, so the data will decide if output and prices have a statistically significant reaction to forward guidance or not. I'll also compare the quantitative results of the state-dependent forward guidance to theory to see whether there's a state-dependent forward guidance puzzle or not. Finally, I'll examine the transmission mechanism and also study the effect on long-term inflation expectations. So quite a lot to do in a short time. So let me get going. Before I say anything about the theory that we use or my empirical approach, I would just like to describe to you what the MPC did in the UK, because most people probably aren't familiar with UK forward guidance. So on the 7th of August 2013, the Monetary Policy Committee of the Bank of England said that bank rate would remain at 0.5%, which at that point in time was the zero lower bound in the UK, so long the following conditions were met. The unemployment rate would stay above 7%, and later those clarified as the key threshold. The Bank of England's 18 to 24 months inflation forecast was below 2.5%. Medium-term inflation expectations remain anchored, and the Financial Policy Committee doesn't point to a risk of financial stability. So those were the three state-dependent conditions that basically the bank rate was conditioned on. And in the MPC minutes, so that's something that a document that published the deliberations of the MPC, as well as in Governor Carney's speech, they said that actually the unemployment rate threshold was key. So it was clearly communicated to the public that was a bank rate stayed at a zero lower bound or not, dependent on where the unemployment rate was. Now, at the time when the forward guidance was announced, the unemployment rate was 7.8%, but it fell much faster than forecast. And as a result of this much faster decline in the unemployment rate, this forward guidance was then changed to focus on spare capacity in February 2014, which that approach, so the focus on spare capacity, was broadly what the Bank of England did before it announced its first forward guidance. So in some sense, the Bank of England switched forward guidance on and then off. So the theory, as I said before, I'm going to use a very simple, perhaps the most simple possible neo-Keynesian model to try and see what state-dependent forward guidance does in theory. And I will explain in a minute which identification restrictions are important for this paper in particular. So this is really a very standard neo-Keynesian model, and sort of the only thing that's a little bit different is this variable ZT here. And ZT you can think of either as a natural rate shock or as a shock to demand. I think of it as a shock to demand. And basically ZT, the stochastic shock, follows an autoregressive process. And there's also, it's basically driven by a stochastic shock. And the rest of this model is pretty standard. And the important thing is that because this shock is stochastic, it can push the economy into the zero lower bound at any point in time. Now, the other thing that's different to most papers in this paper is that we allow IT, the interest rate, to only move in 25 basis point steps. And the reason for this is, as my co-author, who used to be a monetary policymaker, always points out, is that the MPC or most bodies, most central banks, only really go in 25 basis point steps. So, we claim it's more realistic to do it that way. But of course, this means that the solution here is only approximate because there's a discontinuity here. So then the question is, how do you model state-dependent forward guidance in theory? So we modeled as a regime change in policy. So in the standard model, policy just follows a Taylor rule. And if there's a very large realization of ZT, so if there's a large negative demand shock, then ITZ is set to the effective UK lower bound of 0.5%. However, if there's state-dependent forward guidance in that regime, it's pretty much the same as above, but ITZ stays at 0.5% until YT and PyT, so basically the output gap and inflation, imply an I star to greater than IG, where IG is the interest rate guidance threshold. So in the state-dependent forward guidance world, the Taylor rule needs to be significantly above the 0.5% zero lower bound for the central bank to actually lift off. And the lift off depends on the state of the economy, on the output gap, and on inflation. Now we chose a threshold of 1%. And how did we come up with the threshold of 1%? That's not random. Basically, what we did was we took some of the parameters reported in the report that the Bank of England published alongside its forward guidance announcement. And if you parameterize it that way, you sort of get a threshold of 0.85. And because our interest rate only moves in 25 basis points, quarter steps, we end up with a threshold of 1%. And then what I'm going to do, I'm going to show you model impulse responses from the introduction of the state-dependent forward guidance policy. And those are really the difference of the standard and the state-dependent forward guidance model. And the model starts with demand headwind of negative 2.4% to push policy towards the zero lower bound from the start. And the other thing that I do here is I simulate this model, or we simulate this model with lots of many different potential parameters. So this is sort of a standard type of procedure if you want to know which predictions from any DSG model is robust to parameterization. And this is sort of the table. So there's lots of different parameters that we use, and we essentially then take 100 draws and we look at the median as well as the 68th percentile confidence bands. And these are the results from the simulation. So there's a couple of things to note here. So bank rate is basically the future bank rate in some sense. So when you impose forward guidance, bank rate falls and output goes up by a bit, by 0.2%. This is by how much the output gap rises, and inflation rises a little bit as well. As you can see, the confidence bands are quite wide. I think the most important thing, or basically the most important prediction from the model that I'm going to be relying on in this paper is the fact that the standard deviation of the bank rate also decreases. I mean, because this is a stochastically solved model, right? Agents can solve the paths that the model for many different interest rate paths. And essentially what happens when you impose forward guidance, or when the central bank imposes state-dependent forward guidance in the way I described, essentially the standard deviation of bank rate, dispersion of beliefs among the interest rate decreases significantly. So this is sort of the prediction from the model, that the standard deviation of bank rate decreases, and GDP and CPI inflation rise by a bit, but obviously quantitatively these are not very large effects. And then for the empirical section of the paper, so this is the theoretical section of the paper. For the empirical section of this paper, one of the key questions is, well, how do you actually measure the standard deviation of bank rate expectations empirically? And there's 3 different ways of doing it. So, I mean, I think the theory says that it's sort of the change in consumer behavior. So the ideal rate expectation measure should be derived from a consumer survey. And that's actually available in the UK. So in the UK, there's a qualitative survey available, which the Bank of England collects. And they ask essentially around 2,000 adults after every policy meeting, after every quarterly policy meeting, to indicate whether the interest rate goes up a lot, up a little, the same, down a little, or down a lot. So this is obviously only quarterly and only qualitative. Now, the interesting thing is, when forward guidance was announced, you can see that both the mean of these expectations goes down, but also the dispersion or standard deviation of future bank rate expectations goes down, which is sort of in line with the theory I just presented. And then it rises slightly with the second forward guidance announcement, which, like I said before, it's a bit like turning state-dependent forward guidance off.
Tomasz, sorry, really quickly, perhaps I missed it, but in the model, where's the dispersion coming from? You have different agents with different expectations.
Okay, yeah. So this is actually, so where does this dispersion come from? The dispersion comes from the fact that, right, this is stochastic and it's hitting the economy at each point in time, and agents are solving for many different paths of the interest rate, right? So it's one agent basically that solves for many different paths of the interest rate based on the realization of this shock at each point in time. Does that make sense?
But for a given shock, you only have one interest rate.
Realization, that's right.
And one expectation. And you're just saying the dispersion for a given dispersion of the shock, that's how you're mapping the dispersion of the shock to the dispersion of the expectations with interest rate.
Basically, yeah. That's
okay.
right.
Right.
That's right. That's right. So back to the empirical bit. So then another way of measuring bank rate expectations empirically is to look at options, and you can measure implied policy rate expectations and the implied standard deviation. So in the UK, only LIBOR is available, not the policy rate. So I mean, for the US, you can look at Fed funds futures. That's unfortunately not the case in the UK. That's not available. And obviously, there was a big issue with LIBOR because it was reformed after the scandal between 2010 to 2012. And then this reform was implemented in July 2013. So it's really hard to compare this data before and after. Nevertheless, if you just do like a simple event study on the day of the announcement in 2013, then you sort of see that implied volatility, at least 6 months out, in financial market goes down. That's sort of similar to what the first QE announcement did in the UK. And then with the second announcement, you can see that both the rate itself, but also volatility goes up, again, akin to turning forward guidance off. But clearly, looking at the implied policy rate expectation and the standard deviation alone in this paper, probably would be very insufficient because of this LIBOR data issue. And the last one is to look at professional forecasters, short rate expectations. So essentially, you can look at consensus economics 12 months ahead forecast and their standard deviation. And you can see that when forward guidance in the UK was announced, these declined quite significantly. So again, I think all of these data sets are more or less saying the same thing, that with state-dependent forward guidance in the UK, the dispersion, not just the mean of the expected rate, but also the dispersion of rate expectations declined quite significantly. Now, all of these are somehow flawed, as I pointed out, and they probably measure these expectations with error. So what I did here is I assumed this error is linear for each of these series, and I extracted a common factor via an expectations maximization mixed frequency principal component algorithm, the one from Stock and Watson in 2002. It's pretty much like a standard principal component, other than it allows for mixed frequency. And then both this principal component bank rate mean series, as well as the standard deviation, it's also had two additional variables that I add to my VAR. And the VAR I use is something that for internal consistency, I use the VAR that I wrote about before for UK QE. It's the model that I published with Martin in my paper in the JME in 2016. So this is a standard UK QE model, and YT is the vector of the following endogenous variables: is the log of UK real GDP, the log of UK CPI, the Bank of England's QE announcement scaled by 2009 Q1 UK GDP, the 10-year rate on government bonds, the log of real share prices, and then these two principal components. So the principal component of the mean and the standard deviation of the UK short-term rate 1 year ahead at time t. And then I also have a vector of exogenous variables in this model. So those are real commodity prices expressed in sterling at time t. This model is estimated with 2 lags from March 2009 to May 2016, because this is the effective time period for where the lower bound was 0.5%. In June 2016, with Brexit, it appeared that it would go even lower than that, but we want a time period where bank rate was sort of constant the whole time. And there's two different identification approaches. So one is this thing called narrative sign restriction approach, which is basically to say, look, you can identify a shock of interest through a historical event on the variable of interest. And in the original paper of Anselm Diaz and Rubio Ramirez, they require that the US interest rate monetary policy shock must explain most of the historical decomposition in the Fed's funds rate during the 1979 Volcker tightening. Now, our restrictions are basically, so we take this idea, and our restrictions are that if there's a state-dependent forward guidance shock, it must explain the greatest fraction of the historical decomposition of the standard deviation of interest rates of forecast than all other shocks taken together in August 2013 and February 2014, which is the 2 months when the Bank of England made these forward guidance announcements. And also, we apply the same thing to the mean of interest rate forecast. So for both the standard deviation and the mean of interest rates forecast, it has to be the case that there is no other shock that explains more than the historical decomposition than the state-dependent forward guidance shock in August 2013 and February 2014.
Sorry, Tomasz, can I ask a question?
Please.
I was thinking, for the Federal Reserve, there is a survey of professional forecasters, and they make questions for expectations at several time horizons, right? There are expectations for this quarter, 1 quarter ahead, 4 quarters ahead, and then I think 2 and 5 years ahead too. So I was thinking, for that kind of expectations that collects data on the entire horizon, it sort of makes sense, right, to identify the effect of forward guidance. But with this data set of English consumers, do you actually have like many horizons to identify an effect of forward guidance?
So, I mean, I think there's two things. First of all, you know, what I'm looking at is principal components of the consumer level of the consumer survey, the data from financial markets, and consensus economics professional forecasters. So consensus economics professional forecasters for the UK is the equivalent of the survey of professional forecasters for the US. So I'm taking the principal component of all these three. Now, unfortunately, they only all forecast at 1 year ahead. So there are no other questions regarding the interest rate. They only ask 1 year ahead. So that's all that there is. I agree that it would be, we could have much more powerful identification if they gave us more information, but that's all that there is. Yeah. So I hope that answers your question. And let me proceed. So the other way of identifying this is to basically assume that the movements in the standard deviation of rate expectations in August 2013 and February 2014, that they're exogenous. So I can use them as an exogenous proxy variable, basically as an instrument to identify the state-dependent forward guidance shock. That's basically the proxy SVAR approach. And that's what I do as well. So basically, this is a proxy series which has all zeros and only has observations in August 2013 and February 2014, which is basically the change in standard deviation of rate expectations. And I stick while this other approach, while the narrative sign restriction approach, the Bayesian approach, this doesn't work so well when you have sparse instruments. So I stick with a frequentist approach here to generate the confidence bands. And I use the moving block bootstrap approach to generate the confidence bands, because that's basically the one that gives you the widest confidence bands. And then I do something very similar with the local projections IV approach, where the idea is that you can estimate the IRF directly if you observe the exogenous shock. And I use a proxy VAR implied structural shock as the observed exogenous shock in that particular exercise, just to show that the results here are not necessarily driven by the dynamics of the VAR, but are also present in the local projections approach. Why do I use so many different empirical models? Well, the short answer is they all have different pros and cons. And I mean, essentially, the advantage of the narrative sign restriction approach is probably it's the one that requires the least assumptions. With the proxy SVAR approach, on the other hand, you need to assume that this proxy instrument is exogenous. But the advantage of it is, though, is that you can test whether the instrument is weak or not, which you can't do with the narrative sign restriction approach. And like I said before, the advantage of the local projection approaches, you can look at this paper by Nakamura and Steinson, that although local projections and VAR IRF should be the same asymptotically, that's not always the case in small samples. So it's really just a double check of the VAR results. Yes, and when I look at these weak instrument tests for the proxy SVAR, then essentially I always get an F-test statistic above 10, which suggests that the instrument here is probably exogenous, or at least I can reject the hypothesis of a weak instrument. So these are the VAR IRFs, and essentially, let's see what time it is. Essentially, what you can see is that, look, this is a shock to the RSTD, which is basically the standard deviation of short-term rate expectations. And NSR means narrative sign restrictions, proxy SVAR, that means proxy SVAR, LP means local projections, and we always shock this variable, and I always scale it to the same size shock, so roughly 33 basis points, as the theoretical model predicted, or what the theoretical model basically proposed. So what happens in response to this shock is that there's a rise in the CPI, rise in GDP, and interestingly, QE, so the asset purchase variable in the model, basically the reaction is not statistically significant, and that's broadly true for the proxy SVAR approach as well. And in general, quantitatively, the effects, so the fact that inflation rises by about 0.4% and GDP by 0.4 as well, they're more or less the same robust whether you look at the narrative sign restriction VAR or the proxy SVAR results. And then you can look at the local projection results, which are perhaps a lot less well estimated, but they also show positive effects here. QE here seems like it's statistically significant, but I think the important thing to note is that for local projections, the confidence bands probably underestimate the true uncertainty, so it's plausible that it's actually not that different. Yeah, and then what I did is, looking at the baseline results, we can also drop QE. And again, dropping QE doesn't make a big difference to these results. I mean, quantitatively, they go down a little bit, but it's more or less the same as before. So whether you have QE or not in the model doesn't make a big difference. And as you can see on this slide, QE is mostly statistically insignificant, which suggests that we probably identified a state-dependent forward guidance shock, but not QE. And I guess this is where we claim that this is a state-dependent forward guidance shock separately identified from QE. And this is why this is different than for the US or for the ECB. I did a similar exercise for the US, and there you can clearly see that QE has a statistically significant reaction to forward guidance if you try and identify it this way. And then essentially, I mean, in some sense, if you were to overlap the VAR confidence bands with the model confidence bands, and obviously this is a very simple model, but if you overlap them, you would not be able to reject the hypothesis that the responses are exactly the same, just because the inflation confidence band in the model is quite wide, and the GDP one is more or less the same as in the VAR. So it suggests that at least in this model, there is no state-dependent forward in this world, or in this paper, there is no state-dependent forward guidance puzzle. And then I did a lot of robustness exercise around these results. So especially around model specification identifications, we played around a lot of different possibilities. None of them affected the results. I added other variables one by one to the VAR, such as the exchange rate, the trade balance, VIX, policy uncertainty. None of that mattered. And I also added foreign exogenous variables, such as the 10-year bonds, the balance sheet of the ECB, the euro area sovereign risk spreads, US QE, or the US 10-year as an exogenous variable, and none of them made a difference to the results. And then the other interesting question is, how does state-dependent forward guidance actually affect the economy? What's the transmission mechanism? And I think this is the first paper to answer this transmission mechanism question empirically. So what I have here is, these are basically mortgage rates in the UK. So a 2-year 75 LTV rate is the quoted rate. So this is the rate that banks will actually quote you when you apply for a mortgage. And I chose some of the most popular products. This is what the Bank of England makes available on its website. So it's the 2-year 75% LTV rate, the 2-year 90% LTV rate, a 5-year 75% LTV rate, a fixed, there's just all mortgages on fixed rates, all mortgages on a floating rate. And then I also look at corporates. And what you can see that most of the effect of this policy is really by lowering effective mortgage rates. So it looks like banks respond to this policy and they change their beliefs about where bank rate will be in the next 2 years from now. And this effect, at least for a 75 basis point rate, which is sort of a very typical product in the UK, is kind of quite robust across different model specifications. And then the other thing I was trying to investigate was the impact of on long-term inflation expectations. Whether they somehow rise in response to these VAR shocks. And I think interestingly, what we find there is that essentially, if you look at these, so INF 3Y, 5Y, and 10Y, those are inflation expectations from financial markets 3 years out, 5 years out, and 10 years out. And real 3Y, real 5Y, and real 10Y, that's basically the real interest rate embedded in long-term government debt, 3 years, 5 years, and 10 years out. And then I have the city 12 months and 5-year inflation expectations measure. So Citibank asks consumers basically, what is the measure? What is inflation 12 months ahead, and what's inflation 5 years ahead? And I put these variables as an additional 6th variable into my VAR, and you can see that 5 years ahead implied inflation and 10 years ahead implied inflation. There's a statistically significant reaction to state-dependent forward guidance, but it doesn't move real rates. And also, state-dependent forward guidance seems to affect consumers' inflation expectations 12 months and 5 years ahead. So it suggests that there's some effect on inflation expectation. Clearly, one of the reasons I did this is because, as you may know, inflation expectations, especially in the US, but also actually everywhere, are rising now. And it's interesting to know whether this could be due to state-dependent forward guidance or not. And one caveat of this whole study is, as with any empirical study, that I could just be picking up a central bank information shock. So the yield curve steepening, the fact that the long rate goes up, right? So in these impulse responses here that I've shown you before, I always get the result that the long-term interest rate rises in response to the state-dependent forward guidance shock. And that obviously, when I first saw this, had me worried about whether I'm capturing some sort of information effect. And whether that's all I'm actually showing here is an information effect. It's not really state-dependent forward guidance. So to sort of tease this out, I looked a little bit at how to measure central bank information shocks. So for the Bank of England, we can actually measure these information shocks quite well, because the Bank of England surveys professional forecasters 1 week before each forecast publication. So every time they publish a forecast, so every quarter, the week before they publish it, they'll ask all professional forecasters, what is your forecast 1 year ahead for both output and inflation? So I define this shock. And you can have it for both growth and for inflation. So this information shock, the way I define it, is basically I take the Bank of England's forecast when it's released, and this professional forecaster's inflation forecast the week before. So essentially, it's a pretty clean measure of the difference in the Bank of England's forecasts relative to what professional forecasters expected, both for growth and inflation. And you can see that maybe there's a little bit of an effect 1 year out for growth, not really for inflation. When there was the first forward guidance announcement, 2 years out, there's no effect. And what I did was I added these two time series as exogenous shocks into my VAR, and that didn't affect the results whatsoever. So I guess my conclusion from this is that is this an information shock? I think ex ante, this is definitely a risk if you look at the VAR results. But if you include these information shock time series into my VAR, it doesn't change the result at all. So I concluded maybe not. So the concluding remarks here are, look, this is the first paper to empirically study the macroeconomic effects of state-dependent forward guidance, and we use the UK as a case study because the advantage of looking at the UK is that there's no coincidence problem of QE, and the underlying theoretical model is very simple. It's just the standard model from Adam and Billi. And what I find in this paper is that if you look across the range of empirical models I deployed here, I found that a state-dependent forward guidance shock raises output and inflation. These effects are quantitatively very similar to the calibrated theoretical model that suggests there is no puzzle, and this policy is transmitted by our mortgage lending rates and higher long-term inflation expectations. Yeah, so that's all I really wanted to say. And if you have any questions, any suggestions on anything in this paper, it's still very much work in progress. Yeah, please let me know.
Thank you, Tomasz. Thank you. That was very thorough. Does anybody have any questions? We have 7 minutes before the next presentation.
No, actually, my comment is that I think yesterday I asked Vitor on his paper, why not consider forward guidance conditional on some sort of future event? So this paper fits nicely into that question that I made yesterday. So it's a very interesting.
Yeah, indeed. Yeah, we talked about why not use state contingent, at least in the model. And the answer was, at least in my case, was that the agents could always map it into a time contingent. But that actually relates to something I also wanted to mention, Tomasz. And are you aware of the Bank of England guys? Richard Harrison, Matt Waldron, Alex Harris, I think. I'm not sure if Martin is part of that pack in the work of exactly state contingent forward guidance. And if I remember correctly, because it's been a while. So as you said, their work is theoretical because yours is mostly empirical. And I think there, the state contingent forward guidance was different from the time contingent forward guidance in that obviously when you take higher approximations, the dispersion of the shocks matters. Yep. And that could change the time period. While if the agents know the thresholds for the other variables, they can compute that themselves instead of just relying on the bank updating their time forward guidance. And I was wondering if there's any empirical way perhaps in which you could trace out how much is the state contingent factor of the forward guidance helping versus just the communication about the period of extended interest rates. Not sure how we could do that, but something to think about.
Well, that's very helpful. I think that's a good idea. Yeah, I am familiar with their paper, and I think their way of modeling this is much more sophisticated than mine, and I think it's also a more credible way of modeling than mine. I think Richard Harrison has a paper in the JECD, I believe, where he basically models it. Yeah, you can model it almost exactly what the MPC said you can put in the model. Now we chose a much simpler model, I think, for two reasons. Because first of all, this is mostly an empirical paper, and second of all, the reason we like this more simple model is because we're trying to get predictions or theoretical predictions for the purpose of identifying the shock empirically that were sort of as robust as possible to many different model choices. And this is why we went with the simplest possible way that we could think of modeling state-dependent forward guidance. Obviously, this is not the only way to do it.
Yeah, of course. You also mentioned that you did some tests on the US.
Yep.
What were kind of the takeaway differences?
So basically, if you know this Bond against Smith paper that I referred to here earlier, and I'll just put it up in a second. So I did two things. So there's this Bond against Smith paper basically, and they're actually very good because they provide all of the data and all of the MATLAB codes online. So I played with their setup, and when I stuck in my QE measure, so I took the QE measure from my own paper, from my JME paper for the US, I stuck into their VAR. Then the way they identify the forward guidance shock, which is basically using options data for the US, and they try to identify a time-dependent, not a state-dependent shock, but nevertheless, my QE variable is highly statistically significant and positive in response to this forward guidance shock they identified in the data. So that's one exercise I tried. The other exercise I tried is to do precisely what I do, but just on US data. Again, for internal consistency, I took the VAR model I published before in my 2016 JME paper, and I worked off of this. And again, the result is the same. So when you have these forward guidance shocks, at least defined by the way that they were and identified by these other papers, they also tend to lead to a statistically significant rise in this QE series. And the QE series is just the asset purchase announcement. So it's just what the central bank says divided by GDP. So because it is just what the central bank says, right? It shouldn't, in theory, react to a forward guidance shock if you separate it cleanly. So I think it suggests that maybe, it's just very hard to do in the US because a lot of QE announcements in the US just coincide with forward guidance as well.
Yeah, but I was exactly puzzled. Why would it react at all? But that makes a good sense.
I was thinking for the US, there are some indexes of bond uncertainty, right?
Yeah.
So maybe forward guidance could have an effect on the bond uncertainty instead of having on the yields, right?
Yeah. So if you look at so here's the thing. There's also a bond uncertainty measure for the UK, and I couldn't use it in this paper because this measure is produced at the Bank of England internally. But I can tell you that if you look at Martin Wheel's speech, his first speech after this forward guidance, there we showed in an event study that you're right. These indices. So for the US, it's the move. For the UK, there's an equivalent of bond uncertainty. They also react negatively in response to forward guidance. So I think that's another interesting avenue of research that someone could pursue, even for the US. Maybe you could try it. You could see whether that helps identification.
All right, excellent. Right on the spot. Thanks for that.
Brilliant. Thank you so much for inviting me again. I really appreciate this opportunity to get all this feedback.
Yeah, thank you as well. It was very enjoyable.